The problems that we're going to actually see in this lesson regard linear equations using just one variable, and the variable can be any letter of the alphabet, but this particular problem is actually showing fractions, and so the best thing to do to start with is to actually rewrite the problem, because we're going to actually write on top of the problem, and it would be difficult to see what problem we started with and what we actually added. So I always suggest in dealing with fraction problems to rewrite it to begin with. We also want to look at the common denominator for these denominators of 8, 3, and 6, and that is the number that actually 8, 3, and 6 will divide into, which there are multiple numbers that those divide into, but the lowest one is 24. So if we take and put parentheses around each set of terms and place a 24 out front, actually what we're doing is treating each term equally, and we're multiplying by 24. But before we actually multiply, it would help us to simplify this by dividing our denominator into that common denominator. So in this case right here, 8 divides into 24 3 times, 3 divides into 24 6 times, 6 divides into 24 4 times. And the parentheses do mean to multiply in mathematics, so we're going to use our distributive property to multiply. 3 times n is actually 3n. 3 times positive 1 is positive 3. We actually have to distribute to both of those terms. Now, when we distribute 3 divides into 24 8 times, we distribute the negative 8, not a positive 8. Negative 8 times 2 is negative 16. Negative 8 times negative n is actually going to give us a positive 8n equals 5 times 4, which is positive 20. And this is an easier equation to look at opposed to what we started with. We can combine like terms, and on the left-hand side, the terms that are like are the n terms, but you're only adding their coefficients. So 3 plus 8 is going to be positive 11. And then you can add the constant terms, but now remember, when they're opposite signs, you actually subtract and take the largest number's sign. So when I subtract 3 from 16, I get 13, but my sign is going to be negative because my 16 is the larger number and it has a negative sign, equals 20. Now, the idea is that we want to be able to solve this for n, so we need to remove this negative 13 from this side of the equation by adding 13 to both sides of the equation. What we did on one side of an equation needs to occur on the other side. Bring down the 11n because nothing's happened to it. The 13's cancel, bring down your equal sign. 20 plus 13 is 33. And when we solve this for n is being multiplied by 11, so to undo this, the opposite of multiplying is dividing, so we're going to divide by n's coefficient, which is 11. And again, whatever occurs on one side of the equation has to occur on the other side. So when we actually do divide that out, n is all that's left. 1n is all that's left on the left-hand side, because 11 divided by 11 is 1. 33 divided by 11 is 3. But we do need to check our solutions to this, and when you check this, all you really actually have to check is the denominators. You do not want a 0 in the denominator. Well, the only denominators that we have right here are 8, 3, and 6. There's nothing to actually plug in 2. Whereas if I would have had n minus 3 as one of my denominators, I could substitute a 3 into that n, and then 3 minus 3 would give me 0, which means that would be no solution to that problem. So in this case, there is no 0 in the denominator. That's what you're looking for. So our solution is actually 3. Now, another problem that occurs within this may be a problem similar to this one, which actually has some brackets and some parentheses, and this is where your order of operations is extremely important. So in starting on this problem, it's easiest to work from the inside out. In this case right here, the first thing I want to take care of are these parentheses within the brackets, because it's on the inside. Now, to eliminate those parentheses, we need to distribute the negative 4. The sign and all has to be distributed. So negative 4 times n is negative 4n. Negative 4 times negative 2 is positive 8. And we have not taken care of the brackets yet. So this problem is going to be a lot of rewriting. And again, we're going to take care of the parentheses on the right hand side within those brackets first by distributing that 5. 5 times n is going to be positive 5. 5 times negative n is negative 5n, and bring down the negative 6n because we've not had anything occur to that. Now, there's two things that you can do right here. To make it simpler, you can go through there and add your like terms on the inside, which is what we're going to do right here. But you can also distribute it by 3 and then add your like terms, so that can happen in any step. I'm going to add my like terms, so I'm going to bring my negative 4n down. I'm going to add my terms of 8 plus 8, which gives me positive 16. And again, just a lot of rewriting. On this side, I can add my two n terms together, so negative 5 and negative 6 is negative 11, and the n comes along with that, and then I have positive 5, and that can be written in any order. It does not have to be in that order. Now I'm going to distribute. The brackets occur just as the parentheses do, which means we need to multiply at this point. 3 times negative 4n is negative 12n. 3 times positive 16 is going to give us a positive 48. And once I've multiplied, the brackets disappear. Plus 5n equals to negative 20, and again I've got to distribute 2 times negative 11n, which is negative 22n. The terms do not have to be alike to be able to multiply. And 2 times positive 5 is positive 10. Now at this point we need to combine like terms, so I can add negative 12n and positive 5n, and that's going to give me negative 7n. The 48 is brought down. On this side, I can add the negative 20 and the positive 10, and that gives me negative 10. And we'll write negative 22n in front. It doesn't matter which order you write this in. Both of those terms have to be there. The variable can be moved either way. I'm actually going to move the variable to the left-hand side, so the opposite of a negative 22n is a positive 22n. And I'm going to line that up underneath my n term, but again, what occurs on one side of the equation has to occur on the other side. And then I'm going to move my constant the opposite direction, so I'm going to subtract 48 or add a negative 48 to both sides. And again, you have the same thing occurring on both sides of the equation. 22n minus 7n is going to be positive 15n. 48's cancel. Bring down your equal sign. 22n's cancel. Negative plus a negative is still a negative. When your signs are the same, you add the terms and keep the sign. So 10 plus 48 is going to give us positive 58. And again, we have to be able to solve for our variable individually. So to eliminate this positive 15 being multiplied, we have to divide both sides by positive 15. So n is equal to a negative 58/15, and that is our solution. And if you wanted to check this, you could substitute back into the original equation, and the equation should balance out.